At Duke University in North Carolina, scientists have made an astonishing discovery.
Welcome.
I'm going to take part in an experiment to reveal just how we sense time passing. It's all down to something Warren Mech calls the stopwatch.
So you believe that there's a stopwatch in my brain that's sort of ticking away, right? I mean, how can that be?
Well, the idea is that there's a brain circuit in there that's very selective for keeping track of time. And that when we put you in the scanner, we can actually see that circuit at work.
It's going to light up in some sense? Your machine's going to be able to look right in and see certain centers of the brain lighting up?
Well, if we can get you to focus on just the duration of the events in there, that'll put a spotlight on this stopwatch. And so you're right, we're going to be able to activate it and just look right into the brain.
The hope is that Warren Mech and his team will be able to identify which area of the brain is active while I'm timing something.
Michio, can you hear me okay? I'm going to have you respond to those duration stimuli as to whether they're shorter or longer. Are you ready?
It's incredible to think it's actually possible to detect my experience of time passing.
Anita just sent it over. Let's take a look.
Oh, look at that. Oh, wow, that's my brain.
Over here, we're looking for what parts of your brain were activated when you were trying to time the duration of those stimuli.
Warren, look at this. This is by far the brightest part of the timing part of the brain. What's happening there?
Well, this is the front part of your brain where the critical part of the stopwatch is.
It's astonishing. I'm looking at the very cells which sense time passing, seeing them in action.
So this is what's beating then, right? There's a stopwatch is right there.
Right.
Now, what's inside there that is actually beating? Is it a chemical reaction? Is it a nervous reaction? And what is it inside there that's clicking away?
Right. Well, there are thousands of brain cells inside of there that beat in a regulated fashion, and they serve as essentially the tick-tock of the stopwatch.
So even this sense of time passing is embedded within the neurochemistry of our brains. A cluster of cells near the base of our brain releases a chemical that acts as a start signal. This then triggers a group of neurons at the front of the brain to fire together, but each to a different beat. And it's this pattern of beats that signals how much time has elapsed. This process is happening constantly, without us even knowing it. We're continually timing the world around us.
So if Warren is right, it means that he's been able to isolate the circuits that allow us to judge the passing of time. The organ, so to speak, that allows us to measure the beat of time itself.
The discovery of the stopwatch might even explain a bizarre phenomenon. In life-threatening situations, people say that time slows down, so much that they could see every tiny detail. The question is, does time really slow down? Or is it just imagined? We're going to find out. Psychologist Dr. David Eagleman is about to conduct the first ever scientific experiment to explore whether time really does slow down in a near-death situation.
So in order to measure how fast people's brains are taking in information, we've built this device, which we call the perceptual chronometer. And the idea is that numbers flash very rapidly on this LED screen. They flash so rapidly that a normal brain under normal circumstances can't see what's being flashed here. But if time were running in slow motion, then you should be able to distinguish the numbers.
Jesse Callis has volunteered to be our guinea pig.
Can you see that there are numbers flashing on the screen here?
Yes.
Okay, these are flashing at a slow rate. If I
Okay.
speed this up, at some
First,
point,
David has to make sure that Jesse can't read the numbers when time is running normally for him.
that it's very difficult to read what the numbers are. It
Yes,
would be impossible.
very difficult.
Okay, and so are you able to read what's on the screen now?
Yes.
How about now?
Yes.
Okay. And here, can you read the number at all?
No, not at all.
Okay.
Let's just do this number here.
Yeah, great. Is that too tight?
No, go ahead.
Okay. There's no way to fake this test because if time is not running more slowly, they can't see the sequence.
Nervous.
It's a long way down. Slow down. Too scared.
Jesse is about to free fall from a height of 33 meters, 12 stories above the ground. The question is, will he be able to read the number on the way down?
It's great.
Jesse, did you see any numbers on the display?
Yeah, 56.
56, all right, let's verify this. Okay, the number that was actually presented was a 5 and a 0, 50. The 0 happens to look a lot like a 6. So what this means is that, at least mostly, he was able to see a presentation rate that he was not able to see under normal circumstances. Maybe what we can do is try again and see if you get both the numbers right this time.
Again?
Again.
Okay.
Hey, I just watch your head on the side this time.
I find this result fascinating. I would have loved it if he saw both numbers exactly correctly, but this at least suggests to me that he's able to take in information faster than he was before.
It's 96.
96? True?
That's what I saw.
The answer is 98. Hey, that's great.
So for a second time, Jesse has seen a number very similar to the one on the screen.
These results today are very encouraging because this is the first evidence that somebody's brain can speed up and they can see the world more slowly during a high adrenaline situation.
This is the first demonstration that time really can slow down. But how? Back at Duke University, Warren Meck is exploring this remarkable phenomenon by giving mind-altering drugs to rats.
We're particularly interested in drugs like cocaine and marijuana because we believe they can distort time perception by compressing time or lengthening time.